Welcome back. I'm Suchi. I'm part of the team that has developed the CLIx curriculum in maths. In this video, we take a closer look at the geometric reasoning module. We will be looking at its content and how it will be delivered in the classroom. The geometric reasoning module has three important components working together. The first one is the content, the geometric concepts and ideas that the students have to learn. The second is the core mathematical ideas. These help teachers and students explore the structure and nature of the discipline. The third is the processes of mathematics, which help establish a learning environment that is interactive and fear-free. We have spoken about the processes of mathematics in the previous video. So let's now look at the content and core mathematical ideas in the module. Ask a group of high school students this question. Suppose you have a quadrilateral with both pairs of opposite sides equal. Would both pairs of opposite sides be parallel to? You will find all kinds of answers. Some would check lots of examples. Some might take the matter to a higher authority like a teacher, and only a handful, if any, might actually attempt a proof. Research shows that very few high school students understand the need for proof. The content of the module is structured in a manner that provides the students experiences that are sequenced as per the Van Heel levels of reasoning, ultimately leading into activities and tasks that help students understand and appreciate the need for proof. The module is structured into 5 themes, which we call units. The first unit is about some foundational concepts that are mandatory to build further geometric thinking. Understanding the concept of shape. The focus of this theme is to develop a robust understanding of 2D shapes, which are the primary object of thought in high school geometry. They do this by constructing shapes digitally and using matchsticks, and exploring the effect of different actions like rotating or sliding on shapes. Analyzing and describing shapes. This focuses on the next level of reasoning, where students go beyond viewing shapes as a visual whole and start analyzing and talking about the attributes and properties of shapes. The lessons in this theme are woven around a digital game, which helps students explore shape properties in an informal game setting. In the next video, we will cover more about this game. Defining and classifying shapes. From looking at properties of individual shapes, the lessons in this next theme help students progress to an understanding of classes of shapes and develop shared definitions of different types of quadrilaterals collaboratively. Property-based inferential reasoning. This is a critical stage where students step into the realm of inferential if-then reasoning and start appreciating hierarchical class relationships among shapes. Alternate definitions and the role of definitions in maths are also discussed in this unit. The informal game that we have spoken about earlier extends up to this unit. Understanding the need for proof. In this final unit, students will come up with conjectures through inductive reasoning and pattern making. They will verify these, but also learn why verifications do not count as proofs. They will explore cases where inductive reasoning fails, demonstrating why deductive proofs are necessary. These 5 units have some core mathematical ideas embedded in them. For example, in the story-based lesson and discussion in Unit 4, different definitions of trapeziums are explored. This question of whether there could be alternate ways of defining a concept helps students examine the very role of definitions in mathematics. Another example is how the last unit tries to help students understand the need for proof. The module first demonstrates the power of inductive reasoning through exploratory activities, but then it exposes the pitfalls of inductive reasoning too, leading the discussion to the need for deductive arguments and proofs. In this manner, core mathematical ideas are embedded in the units. Now, let us take a look at how we could deliver the module to the students in classrooms. We have spoken of the blended mode earlier, and that is exactly how this content will reach students. A combination of digital and hands-on activities along with interactive class discussions. So, if students were to explore the concept of shape, they would construct shapes with matchsticks joined with pieces of cycle tube, and also construct shapes digitally using turtle programming tools. The core ideas of the lesson would then be brought out in a classroom discussion facilitated by the teacher. Most of the activities, whether digital or hands-on, are planned as group activities to provide the students opportunities to solve problems by actively discussing with their peers. A student workbook which will have the activities and tasks for all lessons will be made available for students. There would also be guided explorations in GeoGebra to help students gain confidence in making and articulating conjectures and then verifying them. Each lesson would also include classroom discussions, where you will have an opportunity to consolidate students' learning through discussions. You will be provided teacher notes. These have ideas for facilitating the discussions and a space to note down your reflections and observations there. The assessment in the module happens in various modes. There are worksheets that students need to work on, there are digital assessments, and there are reflective self-assessments that students do. But most importantly, all the classroom discussion by themselves are excellent assessment opportunities. In this video, so far we have spoken about the 3 important components that work together for the geometric reasoning module: the content, the core mathematical ideas, and the processes of mathematics. We looked at how the module is structured into 5 units of understanding the concept of shape, analyzing and describing shapes, defining and classifying shapes, property-based inferential reasoning, and understanding the need for proof. We then spoke of how these modules will be delivered in classrooms through a blended mode that involves both digital and hands-on activities along with classroom discussions. One of the core digital activities in the module is the learning-based game Police Squad, which students play across weeks. We will talk more about the rationale for selecting game-based learning and this game in particular in the next video.